Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question which is based on the input impedance and voltage gain of common gate, common source and common drain amplifier based a numerical. Okay, in that particular numerical, we have to identify which of the sentence or statements are correct, okay, or true. So the question is, which of the following statements each or are true with respect to ideal MOSFET based DC coupled single stage amplifier having finite load resistor? So the option A is the common gate amplifier has a infinite input resistance or infinite input impedance. Common gate amplifier has an infinite input impedance. The common source amplifier has an infinite input resistance. Common source amplifier has an infinite input resistance. The input and output voltages of the common source amplifier are in phase. Okay. And the last option is the input and output voltages of the common drain amplifier are in phase. So here what we observe that the question is based on common gate amplifier, common source amplifier and common drain amplifier. Here also common source amplifier. This one is common. Okay, common source amplifier. So all three, common gate, common source and common drain. So what I did first, I have draw the circuit symbol, circuit for the common gate amplifier, common source amplifier and common drain amplifier, and we will derive. Okay, very quickly we will derive all the input impedance and basically voltage gain. Input and voltage relationship we have to know to check it is in the same phase or in opposite phase. Okay, or 180-degree phase shift. Okay, so first we will go for the theory. Okay, a brief theory. So first of all we will look for the common gate amplifier. Okay, so here I have already draw the common gate amplifier, common source amplifier and common drain amplifier. So basically what we will do, first we will go for the small signal analysis. Okay, we will go for the small signal analysis for all this structure. A small signal analysis to determine the ZI and AV. Basically, in the question, they are asking about the input impedance or input resistance and the voltage gain, in which input and output are in the same phase or opposite phase. So, first of all, we will go for the common gate amplifier. So, for the common gate amplifier, what we will do, we will draw the basic small signal model. So, first of all, what we will do, first we will make the transistor. Okay, and this will be like this, a small signal GMVGS. Okay, and this value is our this voltage VGS, and gate is connected to ground. Okay, so common gate is there. Okay, and one RD is there, RD, and this one will be our V naught, and this capacitor will be sorted. Capacitor will be sorted. Okay, capacitor sorted, and we are giving input across this side Vi. Okay, so this one is the circuit. Okay, clear. So now we have to find the input impedance. Okay, so for the input impedance what we will do, I am saying some current is flowing I. Okay, or better to write a small I for the AC current. Okay, so if we find this, we have to find the value of Zi. So Zi is nothing but simply Vi by II. Okay, Zi equals to Vi by II. Okay, so if we apply, okay, now a small signal model is this one. So if we apply KVL in this loop, I am saying KVL in loop 1. Okay, if we apply KVL in loop 1, so what we can write simply minus VGS minus VI equals to 0. This one is plus and minus. So apply simple minus VGS minus VI. So we can write VI equals to minus VGS. Okay. And this current is II and this current is our what? ID. Okay. So the current and this one is our, we can say, the gate in, this one drain and source at point S. If we apply KCL, what we can write? II, total incoming current, II plus ID goes to 0. Simple. Okay. So II value is nothing but simply minus times of ID, or ID is what? GMVGS. So what we can write? GMVGS. Okay. Now VI is known to us, II is known to us. So we can simply write ZI by II. Okay. So VI is minus VGS and this one II minus GM VGS. So this VGS cancel, minus minus cancel. So it should be ZI 1 by GM. So it is in ohm range, and ideally its value will be nearly equals to 0. Okay, in ideal case. Okay, when GM is high, it should be ideally 0. It will approach to, but practical means value will be 1 by GM, but ideally we can say it have 0 resistance. Few tens of ohm resistance will be there. So ideally we can say the value of ZI will be 0. Is it okay? Now the another thing that we have to determine, because in the question they are also asking about the gain. Okay, so this is the input impedance, and for gain, that is our voltage gain, or better to write voltage gain. Okay, so for voltage gain calculation, what we will do? Okay, so now for voltage gain, again from this side, if we look, what we observe that the value of V naught can be written as minus GMVGS into RD, minus GMVGS into RD by, just see, this voltage is V naught and this voltage is 0 volt, and this one is RD, and some current is flowing from this side, ID. Okay, so ID is our, nothing but simply GMVGS. Okay, so what we can do, we can write ID equals to 0 load, higher potential, because current is flowing to this side, so 0 minus V naught by RD. So V naught equals to minus RD, and ID is minus GMVGS into RD. So V naught is minus GMVGS RD. Okay, V naught is this minus GM. How it is coming? It is clear. Now input impedance is finite. Okay, so ideally it is 0. Okay, so next one, this V naught is now known to us. Now we have to find VGS value. So for VGS, okay. Now from this one, if we apply VI equals to minus VGS, VI equals to minus VGS. It is VI equals to minus VGS. Yes or no? So VI. So now we have already find the value of VI equals to minus VGS. One more time I want to show you. VI equals to minus VGS by applying KVL in loop 1. Okay, so now this one is one expression. So V naught equals to minus GM. VGS is nothing but simply minus VI. So minus VI RD. So what we can write? V naught by VI equals to GM RD. So this is the expression for the gain. So in case of what we can say, in case of common gate, the input resistance or input impedance will be zero and voltage is in the same phase of input voltage. Okay, so first we will go for the common gate. What is the common gate? In common gate amplifier has a infinite output resistance. So this one is the wrong one. It has it has so this one is a wrong statement. Okay, this one is our wrong statement because it has finite input resistance, not infinite, or it has some finite input resistance because it has a finite input resistance. Okay, so in common gate amplifier finite, so this one is wrong. This now common source, so common source amplifier infinite input resistance, the common source are in phase, so that we have to determine. So for that purpose we have to go for the common source amplifier. So now common source amplifier I have already drawn. So first what we will do, we will do the small signal analysis. So we will draw the S equivalent model. So I am just doing the S. You have to know this S equivalent model, means how to draw plus minus VGS, and this one is GM VGS. Okay, and RD, this should be V naught, this is our VI, this is our gate side. Capacitor will be sorted, so gate, drain, and source. Okay, so first we have to find the input impedance, and I am saying this current is II. Okay, so this one is our input impedance. So Zi value will be Vi by Ii, small ii. AC current, so small, right? So Vi have some significant value and there will be no correction. So it should be, the current will be zero. So it should be Zi value is infinite. It is clear? Zi value will be simply infinity. Okay. In common source amplifier, input impedance will be infinity. Okay. Now we have to think about the gain. Okay, so V naught is simply our minus gm vgs into rd. Okay, I have already solved, means how, means this value is what, id, this one is a small id. Okay, so id value will be 0 minus v naught by rd. So v naught equals to minus id is gmvgs. So is it okay? And I have already solved here this one. This one, if we take a look of this one, it will come. Okay, clear? Minus gmvgs. Now vgs is nothing but simply vi. Vgs is nothing but simply vi. So what we can do, v naught equals to, we have to put this vgs uh, in this one above equation. So it should be minus gm, minus gm vi rd. So v naught by vi equals to minus gm rd. So here there is a negative term. V naught is minus gm rd times of vi, already written. Okay, so here this minus sign, this minus sign, this minus sign, this v naught equals to minus gm vi. So output is in opposite phase of input. Okay, so there is a phase change and input impedance will be infinity in a common source amplifier. So we have to select the, so the common source amplifier has infinite input resistance. So is it okay or not? Infinite input resistance? Yes, it is okay. It has infinite input resistance. Okay, clear? This one will be the correct one. Okay, it has infinite input resistance, we have already defined. And common source amplifier are in phase. No, it is not in phase. Okay, because v naught equals to minus gm, so v naught is out of phase of vi, because v naught equals to minus vi. So if v naught is like this, if I am saying this one is v naught, then the corresponding input will be out of phase like this. So this one will be the vi, so opposite phase. Okay, so we can say the third option in common source amplifier, the input and output voltage of the common source amplifier are in phase. No, okay, they are in opposite phase. So this will be also correct, not correct. Okay, we have to make it cut. Okay, now the input and output voltages of the common and amplifier are in phase. So what we have to do, we have to think about the common drain amplifier. So what I did for the common drain amplifier, first we have to draw the circuit in which drain is connected to VDD. So this part is common to both input as well as output. So we have to draw the AC equivalent circuit. So what we will do, you have to practice 4 or 5 times, then it will be very clear. GM, VGS, this will be drain side, so it is connected. Okay, so this one is our drain, this one is our gate, and this voltage capacitor is sorted VGS. Okay, and this will be the VI and RS. Okay, and we are taking output across the source terminal, that is our this source side. Okay, so this one is the circuit. Okay, so the here also we can say the input impedance will be infinity. Zi will be infinity. Okay, we are not focusing too much. Zi Vi by Ii, Ii is 0. Okay, Vi by 0, it is infinity because circuit is not closed. Okay, so now we have to find the gain. Okay, so this point is V naught. Okay, so what we can say, this one is our V naught and this one is VGS. So if we apply KVL in this loop, KVL in loop 1, okay, like this, by applying KVL in loop 1, what we will write? Simply plus Vi, okay, so this plus or minus, so plus Vi minus VGS, and we can write it minus V naught equals to 0, or V naught equals to Vi minus VGS. Is it okay? Simple expression. Clear? Now, next, what we can observe, this current is what? ID, a small ID. There is no current, so again this ID will come, ID will come. So one resistance is there, okay, that is our R. This voltage is V naught, and we know the current is flowing through this one is GM VGS. So V naught equals to GM VGS into RS. Okay or not? Simple. This one is the resistance, okay, RS. V naught voltage is there, okay, RS, and the same kind GM VGS is flowing through this RS resistor. It is grounded. So we can write V naught equals to GM VGS, the current, into resistance IR. Okay, V naught equals to IR GM VGS into RS. Okay, so now VGS expression, we say this was equation number 1, equation number 2. So from this one, VGS can be written as V naught by GMRS. Now we have to put this VGS value in equation 1. Okay, so what we can write, if we put V naught equals to, from equation 1, VI, we are taking this expression. Okay, V naught equals to VI minus VGS. So V naught by, simple calculation is there. So V naught will be 1 plus 1 by GMRS by, equals to VI, or one more line I want to write, GMRS plus 1, okay, into VI GMRS. Okay, and one final line. Okay, so V naught is okay GMRS by 1 plus GMRS into VI. So V naught VI in same phase. So V naught and VI is in same phase. Okay, this one is the expression that we have find. Okay, so this V naught and VI is in the same phase. Okay, in a common drain amplifier and input is high. So we have to check only one statement is there for common drain. So the input and output voltage of the common drain amplifier are in phase. So this one is also correct option. Okay, correct this one. Okay, I have put it the green color. So this one is also correct one. So in this question, we have identified there are four statements are given. So we have to select the correct one. Correct. So there are two correct options are there. So the final answer will be which are the true. So the second point. Okay. So the second point that is our this expression is the true one. True. And this B and D are the true. Okay, so this one is the true expression, true statement. So this is all about this question, but we have to know the basic. Okay, I have made the very simplest diagram, okay, to solve this problem. So like that you can do, means for a small signal analysis, then easily you can identify how to do the calculation and all. So we have analyzed the circuit, and all three configuration are there: common gate, common source, common drain. So basically we have find the only the input impedance and the voltage gain for the input and output voltage, uh, uh, is in phase or not in phase. So that's why we have determined the voltage gain. So this is all about this simple video lecture. So thank you for watching this video. Thank you.